Hey, what's up, everybody? Welcome back to Pathways to Healing, the Perfect Step podcast. We're your hosts, Cody Norman
and Logan Fry, process recovery specialists at the Perfect Step, also known as TPS.
We are not doctors and are not prescribing anything, as this podcast is for informational purposes and should not be considered legal advice.
We are, however, sharing knowledge and experience that we have gained from working for years with clients in the paralysis community.
The guests on this podcast include members from the paralysis community sharing their perspective and insight.
Suggestions and advice that we share may affect each person differently, as not one injury or diagnosis is the same. On this episode of Pathways to Healing, we interviewed Dr. Maya Hatch. Maya Hatch is a researcher at University of California, Irvine that specializes in spinal cord injury.
She covers many different topics of research in this episode, including how and why she got into the field of research studies that she's done in the past, the current studies that they're doing at UCI, and where she thinks the future of research is going. She does these in a very elementary way so that even we can understand these complex topics. Stay tuned on Maya's Pathways to Healing. Welcome back, everybody, to Pathways to Healing. On today's episode, we have on Maya Hatch. Maya, thank you for coming on.
Yeah, thank you for inviting me. Glad to be here.
Absolutely. First of the year, Maya. We appreciate it. You being on.
Stop doing that high pressure thing. First of the year, no pressure.
Not at all.
Not at all. Maya.
This will be good.
Yeah, exactly. If you don't mind, Maya, would you mind giving us all a little general background about your story?
So I'll be technical first and let you ask questions because that's my comfort zone.
Great.
So I'm not a MD doctor. I'm a PhD. So a little bit different. So did the typical path. I went to college, mastered in, or got my degree in biological sciences. I got 2 degrees actually in my undergrad. Knew I wanted to do science. So I've been doing science my whole life. And then immediately in college knew also that I wanted to go into the PhD program. So I was exposed pretty young. My mom was the head administrator at a hospital, a local hospital where I grew up. And so I grew up in the hospital quite a bit. But I knew I wasn't wanting to be a doctor. So I always tell people, because they always ask like, oh, how did you know you wanted to do PhD instead of MD, right? Because a lot of the training is the same. And for me, it was always like, do I want to treat people, and cure them all day long? Do I want to figure out what's wrong with that person? Mm-hmm. And so I'm more that. I want to figure out why it doesn't work or how come it doesn't work or how do you make it better? So I was pretty young. I had a couple of MD, family friends that would show me around the hospital just to be like, make sure you know what you're getting into. So when I went to college, fast forward, I already knew what I wanted to do. So I started doing research as an undergrad because I knew I wanted to do that. And then from there, I went in and got my PhD. So I did get my PhD and my undergrad at UCI. And I went there on purpose because at the time that I was there, they had spinal cord injury research. It was one of the only places here in California that was doing it at a level that I was aware of. So I went straight into the PhD program, got my PhD, and technically it's in anatomy and neurobiology. So I did animal models of spinal cord injury, so mice and rats. So worked down in the dungeon in the lab all day long. But got exposed to human stem cell transplantation into that. So really translational work. And then from there, I really knew that I wanted to jump into humans with spinal cord injury. So from there, I then did a fellowship or a postdoc at the Long Beach VA for 3 or 4 years and got specialized. So I did 2 things when I was there. I bridged into clinical research, which is research on human subjects, and learned and got integrated into all the spinal cord injury care, the vets there, the whole system, which was wonderful. And then I also did like a statistical specialization where I learned how to do statistical modeling from things that come from the hospital records and how to determine and pull data from hospital records on outcomes, how people are progressing, what comorbidities they have, and then how you quantify their recovery. So I did like a statistical math component, and then I was down in outpatient rehab basically all the time doing the research there. So I've been in SCI pretty much my whole career, even though I've also now branched into other things. But SCI has kind of been my love for the research. And then after I finished my fellowship at Long Beach, I came back to UCI in the PM&R department to continue on with the work that I started there.
What do you have your undergrad in? What are the 2 undergrad degrees?
So it's just biological sciences, and then I also specialized in molecular bio and biochemistry.
And is that why you picked UCI in the first place? Or what was the reason?
I was not that good of a picker when I was in high school. So I knew I wanted to stay in California in high school, and I knew I wanted to do research. And so I applied to a lot of the universities, of California. But I really also wanted to come to Southern California. So it was kind of like the farthest away from home. Then I thought San Diego was too far and it was too away from everything else. And so it was basically like the farthest away from home that was SoCal, but not the end of California. That seems like a weird way of choosing, but that's basically
Right. Yeah.
I would like to say it was more tactful at high school, but it was not. It was like, I was like wanting to get out of my hometown and experience bigger things. And so, yeah.
You got close
And
to
I
the beach?
thought LA would be too crazy.
Yeah.
I was like, oh, that's a little too crazy.
I feel like everybody from Northern California wants to go to Southern California and
I
vice
know,
versa.
right? Well, and my
Get
whole
away.
family, my parents, my aunts, my uncles, all of them went to Berkeley. So I grew up in San Francisco at Berkeley. So of course, that would have been a great place for me too. But at the time, I was like, no, I want to do something different. Right. So, and no one came down here. So I was like, okay, let's go to Irvine.
You said spinal cord injuries, your love for
One concept.
research.
Yeah.
What was it about spinal cord injury that really grabbed your attention in the first place? Why did you get into the field?
So I first started learning about it in anatomy in high school. I had a really good anatomy teacher when I learned I was very good at anatomy. And I loved the spinal cord. I loved the brain, like the central nervous system. I was in love with it. And so then when I got into it a little bit, into a lab that I started working with as an undergrad, it was just fascinating to me. And over the years, I was always like, why am I drawn to this? Why am I drawn to this? And so I've kind of thought about that. And I think it's 2 things for me. I love the nuts and bolts of things. And I feel like the spinal cord itself and the brain are the nuts and bolts, or like, the engine of the car, right?
Definitely.
I love that, even though it's very complicated. I seem to really like complicated things. That. And then also, honestly, like, I've just never felt any other domain of research that I worked in where I feel so comfortable with the people and the community. And I think that if I go back and think about it, like, I'm an adrenaline junkie. I do a lot of sports. I mean, at any given day, that could be me. And that's how a lot of people get injured, from doing the same things that I've done my whole life. So I did downhill mountain biking. I motocross. I, ride motorcycles. I snowboard. I jump out planes. So it's like any given day, I feel like that could be me. And I think it's the personality that I jive with people that are injured. It's just like any given day that could be me. And it's kind of like someone told me once when I asked him about his injury, how he got hurt. And he's the same. He's like kind of an adrenaline junkie. He was a racer, blah, blah, blah. And he said, doc, that day I just bobbed instead of weaved. And I was like, so true. Like, that could be any of us, right? He's like, it's just a fluke thing. I just bobbed instead of weaved. So you just got to go with it. So it's a weird thing because I'm fascinated by it. And then at the same time, I've always been drawn to the people and the community. And I've always felt just like a familiarity, if that makes sense.
Definitely.
But I think it's because I'm crazy and I get it. And everybody is also kind of, they're doing hardcore things. And so that's how a lot of people do get injured.
The Be Perfect Foundation is not just a name, it's a promise. A promise to individuals living with paralysis that they are not alone in their journey. Founded by Hal Hargrave Jr. in 2007, after his own life-altering accident, we are a nonprofit 501c3 organization dedicated to providing direct financial and emotional aid. Inspired by a quote from the movie Friday Night Lights, we believe that being perfect is about doing everything you can, especially for yourself, your family, and your friends. With nearly $10 million raised and a 100% volunteer staff, your support goes directly to those in need. We assist with medical supplies, wheelchairs, home adaptations, and exercise-based therapy programs. Our board of directors receives no salary, ensuring that almost every dollar donated makes a real impact. Visit BePerfectFoundation.org to donate or learn how you can get involved. The Be Perfect Foundation, changing perceptions daily.
So talk to us a little bit about the research that you're currently working on within SCI, and where are you working on that research at?
Yeah, so right now is some super exciting stuff. This is, I would say, the best part of my career thus far. So right now, what I'm doing at UCI, I am in the PM&R department, but I also work at Irvine Research Institute. And normally the Irvine Research Institute does basic science. So they do animal models and they do, regeneration, axon regeneration. And I've really started the first clinical program there. And the big thing I'm doing right now in the SCI research domain is I have a current study going on developing a new way to measure trunk control in spinal cord injury.
Interesting.
And so this whole thing actually came from my time at the Long Beach VA. And it was just a huge gap. So I said I did that fellowship, right, where I was like integrated into the VA and then doing that math and statistics. But the other half, when I was in the rehabilitation area, what I was trying to learn how to do is how do you make and optimize outcomes? And in the health domain, if you don't know what outcomes are, when you go to the doctor, they do a bunch of tests and they measure how you're doing. Some of those tests are like blood tests and urine tests, but some of those tests are functional, right? How are your arms moving? How's your body moving? How are your legs moving? And so I specialized in that, functional outcome measures, ways to track whether you were getting better, whether you were getting worse, but just ways to track your function. But I specialize just from the waist up. So I do upper extremities and the shoulder and then the trunk or core.
That is I'm going to call it a tool or the machine that we kind of got to see a little bit at the Meet the Researchers.
Oh yeah, meet the scientists. Yes, yes.
Yeah, so a literal tool that you use to measure the difference in the pelvic tilt to understand the balance.
Yeah, so it's
Flexibility.
come a long way since then. Yeah, that was like,
But that was the same.
I would say like pre-beta version. So the cool thing, so let me back up just a little bit. So in the rehab space, in inpatient or outpatient rehab, the way you would measure if someone was a spinal cord injured individual in the hospital and a therapist or someone wanted to measure whether they have good, core or trunk control, maybe they'll have you lean a couple of different ways on a mat. One of the things they have you do is they have you lean all the way forward and they see if you need assistance or not assistance. It's a very gross way of saying someone has control. Or maybe they'll train you to do, a seat transfer from your chair into the, mat, or from the mat into the chair. Same thing that you would do from like the toilet to your chair to your toilet. So they train that and they test that. And they basically say, you can do that independently. You can do that with assistance, or you need total assistance. So it's very gross. It doesn't really tell you if someone's getting better or not. But it was meant to just be a way of knowing you're ready to go home, right? So then if you come back for like outpatient, you're doing some kind of physical therapy intervention with exercises. They have this big device, if you've seen them at some places, and it's a force plate. So they have this big, huge device. Usually they have people stand in it, and then this plate measures how you distribute your weight back and forth. So it goes front to back, and it can also move. So it's called a perturbation. Yeah, it'll tilt you, and then you'll have to react. That is typically only done when you're standing, though. So if you're someone that can't stand, you don't do that. So there's really nothing. You could have one of those force plates, which I have now, that is now adapted where it's not a standing one, and you can sit on it. And then you can also see if if they're stable or if they're just kind of wiggling around, what we call sway.
Could you, in a similar fashion, do it in like the hands and knees position from the knees up?
That would be hard for people because it depends on if they have that mobility as well. Yeah. And some of that is going to be pressured onto your legs first in tandem with your trunk. So you're not separating those two strengths, right?
Yeah.
So you would want to do it while they're sitting on their butt somehow.
Where are their feet when they're sitting on that plate? Like, are their feet planted? Or are they hanging off in the air? Are they
No, they shouldn't be hanging. They should at least be the same height as the length of their legs. So that 90-degree sitting position. So they're at least resting.
Okay.
But like extended.
Still not done that much. So like, and the reason for that is those force plates are really expensive. And so a lot of rehabs don't have them because they're very expensive. A few rehabs do have them, but the problem also is they're very technical. You have to maintain them. The equipment is, takes a lot of maintenance. So they're really just like prohibitive. So a lot of people don't use them. So when I was at the VA, I was actually working on this big study that they had that was sponsored at the time. You probably remember it was the ReWalk study for spinal cord injury. So I was on, our site had that, and I was on that study where they would actually put you upright in the ReWalk, and train you. And then you would take it home and walk with it at home. But anecdotally, during some of those training sessions with the veterans, a couple of them had said to me, like, I swear, because of the way you have to walk in the ReWalk, you have to tilt forward this 1 degree, and then it activates the opposite leg to move. Right. And then tilt, move, tilt, move. So you're doing this like balance tilt. So a couple of our veterans were like, I swear, just from doing this training, because it's intense training for several weeks, my core is getting stronger. Like I'm sitting better in my chair, I'm transferring better. And they're like, how do we measure that? And I was like, I don't know. It's kind of like, we don't really have a good way to measure that. And so literally one of the vets said to me, Doc, you're really smart and stuff. You know that techie stuff. Why don't you figure that out? And I was like, challenge accepted. I was kind of like, oh, you have a really good point. And then I started kind of dissecting it as I was working every day and started asking, people in the gyms there and the rehabs there, like, would you say trunk control is like really, your core strength when you're sitting at home, even though you can't stand, do you think that's really important to you? And everyone was like, oh my God, yeah. Like, so then I started hearing all these stories. And then I started talking to some of the therapists, and it was just like, this really just isn't, there's nothing out there. And in tandem at the same time, like I told you, I don't just do spinal cord injury. I also do some other areas, still in trunk control and the upper extremities. But at the time, I was also learning and working with a team on an upper extremity measure. And we were using the Xbox 360 Connect sensor. So the thing that everyone put in their living rooms at home, yep. Right? You're playing tennis or whatever at home. Well, that can track all of your, motion of your body. Right. It individually tracks your arms. It tracks your, thorax. It tracks your hips, your legs, your head, all of that stuff. So it automatically in that system tracks that. And it's the same thing as like motion capture, just in a really tiny device that can go in someone's living room.
Interesting.
So we were using that to look at arm function and how in various conditions, when you're declining in your arm muscle control, how that changes. And so it was kind of like, well, couldn't we use that to do a trunk measure? You can still, it was the same kind of thing. It's just like a tripod. You stick it on a tripod, hook it up to a computer. Yes, you need some kind of fancy collection system, to do that, to record it as well. But that's all it would take. So you're talking about like an Xbox 360, which at the time was probably $300 or max back then, maybe $500. And then just, you had to build some good software to collect it. Microsoft had a developer kit though at the time, so you just needed some engineers to filter the data, but you could get all of what the body was doing. And so that's basically what it's turned into for me now is, so what you saw 2 years ago was just a picture of that, right, with the collection software. Yeah. Showing that if I moved around, it would just track you. And if I raised my arm, you could see it. So in that same way, you could do any type of arm movement, trunk movement, head movement, but you just have to find a good way and a reliable scientific way of testing balance. And so then that became the development over the past couple of years. What are the things that how are we going to test trunk stability, and how are we going to do it? Standing, sitting, etc.
So you mentioned various conditions when you were speaking about that. So what are some other people that you also tested other than spinal cord injuries? What other neurological
On the
disorders?
trunk one, not yet. Just starting in spinal cord injury. For the upper extremity one, I work heavily in muscular dystrophy. So I work, and muscular dystrophy, it's a genetic disorder. There's a couple different kinds, but they're all some kind of genetic-based condition where they have continual loss of function, so muscle weakening in various ways. I work in FSHD, which is facioscapulohumeral dystrophy, and it's a weakening of your shoulder girdle and arm muscles. And so it also then moves to your trunk and then progressively moves to your leg. So eventually I'm probably going to translate some things into that domain as well. But right now we've just been developing things for the upper extremity function, but looking into the trunk for that as well. People keep asking, because once they hear about this whole, trunk outcome and the testing measures, they're like, oh, what about Parkinson's? What about and stroke? What about, so there's a lot of things that could go into, but right now I'm developing it in spinal cord injured individuals first, because that's sort of been my goal. And then it might have to change a little bit depending on the condition. The nice thing about spinal cord injured individuals are it should be neurologically based. And there are postural testing that we can use while seated, I think.
So we have a few pretty high level C-level clients in here that are not able to sit up on their own at all yet. And so what are some ways that you guys would help with those kind of individuals that are unable to sit up on their own or able to test trunk control at all? Is there a wedge or something behind them while doing that
Yeah,
test?
you're ahead of me. I haven't figured that out yet. Right now, we're first doing the testing in thoracic level injuries. So,
Okay.
for that very reason, because there are some testing movements that are known. So these leaning tasks with and without the use of your arms, we know those are controlled by the way you place your upper body over your center of, so your base of support. So you're sitting, you have this base of support, this area.
Right.
And you move your trunk within that area to certain limits, depending on what muscles you have. But for cervical, the idea is this is your cord. You have a level all the way up here, and everything below that, or a lot below that, is supposed to be inhibited or limited. And all of the innervation that comes from your spinal cord for your core muscles comes from the thoracic region. So anyone above that is going to have very limited or sparing amounts of that.
Definitely.
And you're not going to have the activation of those muscles, which is why the sitting is very hard.
Absolutely.
So right now, it doesn't apply to them in the way that we're doing it. And we're still trying to figure out how. Because moving down the line, the reason we're trying to even develop this in the first place is because you have all these new things coming out that could help. So right now we know like epidural stimulation is good. People have been testing it during walking. Theoretically, it could also help if you have residual innervation in your trunk, right? So you could have that. If you don't want something that's that invasive, you could do, right now the transcutaneous stimulation is going very well. And it's the same idea, just not invasive, right? Same thing though, if you move that up a little bit into those areas that innervate your core muscles, you could improve that for someone. That could, for a cervical level, if they're not complete, happen, right? So we have to be able to measure it properly to see if it's working for these interventions. And that's why we're trying to create this in the first place. Haven't gotten to the cervical level yet though, because that is a challenge. Right now, we're at the interim state, like the early stages of, I have to prove that the tracking with, the Xbox 360 and that system of tracking is just as good as what exists. I have to compare it to the force plate right now because that's the only existing thing. And that is a limitation because only the force plates don't have all the guards and everything. So I have to feel confident that I can put someone on that plate.
And it's safe.
Right? Okay. So the idea for me is let's start in the thoracic because there's going to be a lot of variability, right? Higher thoracics are going to have less control than lower thoracics. So I'll see a lot of differences. But I just first need to show that my new thing is just as good as the old thing. Once I say, yes, it is, you can take that away and then we can start exploring.
Cervical.
Exploring higher, because then I can do it on a normal therapy mat You could have rope systems or something that are a little bit of support.
Okay.
The movements would probably be less challenging than the ones I'm doing right now.
What are some of the movements that you guys are doing, and are they for the most part uniform for everybody?
Yes.
Okay.
So they are standardized across everyone. How they do them is a little bit unstandardized, but that's what we're trying to track.
Okay.
But there's a standardized set number. Right now we're doing 16 different movements, and they're leaning tasks. So they're leaning in different directions, in all directions. And then some are even harder by crossing your arms so you can't compensate. And then sometimes you can by having an arm out. And then we're doing some twisting. So we're trying to do enough leaning tasks that test the various on both your right and left side.
Have you guys ran into any anatomical challenges with SCI? Kind of from what we've seen, you get anatomy changes in the body when the body is in the chair, a certain position for so long. Have you ran into changes in anatomy, whether it's in the pelvis or other regions, if you're doing upper extremity stuff in the shoulders or stuff like that, that's complicated that?
I'm taking notes on people when they let us know certain things, like if they've got rods that they know about in certain placements. And then if for some reason they're having current issues with tightness or hips or something, that we probably won't test them actually, because that's going to have some degree of an effect. So right now we're kind of omitting that or recording it, but not omitting them from the study. So if they have some surgical, and a lot of people are going to have rods, a lot of them. So we actually assume everyone, especially that are probably less than 10 years of an injury or something, they're all going to have rods. Yeah. And that's going to be a stabilizer by itself.
Right.
But if everyone has it, then it's still hopefully, what you can do is going to be different than someone else with a different injury. The only thing that we remove right now, like I said, is if people are having chronic lower back pain to the point where like they can't sit for that long, we're not testing those either. Not right now, because the plates are just so stiff and firm.
Until you can move on.
Yeah.
Until you get the baseline that this new thing is as good as the old thing, and then you can kind of
exactly.
run into all these.
Then we can broaden a little, and we can broaden some of the movements as well if that's needed. So right now we're limiting it, not so much. Obviously, anyone that has any existing pressure ulcers, like also in that area, we would never want to make that worse. And then the same thing, it does happen where, you move, and because you're moving, it activates some spasms. So we've had that in the middle of the testing. That's been interesting because sometimes I'll say, okay, let's stop, give you a rest, let it go, and then we'll try again without the spasm. But a few of them, yeah, it does sometimes. But sometimes it's like they just need to almost stretch it out, let it go, and then they can do it again, and it won't be there. But
Anybody had any low blood pressure issues when doing this, or any autonomic dysreflexia?
not yet.
Okay.
Yeah, we've been lucky with that.
Okay.
We take it at a pace the movements are also like, we don't push them in pace right now. It's kind of like do it where you can maintain control. So people do tend to right now do it fairly slow, which is fine because they're trying to find the maximum that they can lean. And we obviously let them practice. So right now we haven't had any AD or anything like that or any problems, just the spasms. A few times, I've been like, hey, can we record the spasm? Just because I want to see. So what'll happen is, if someone spasms, sometimes they'll tilt their hip and pitch it. And I'm like, okay, can we see that? Can we see that on the motion capture? So I've been recording some of those just to see if we can see that and see how it interacts. What you saw is true though. Like I can already see the way someone's sitting on the plate because of their skeleton. I can see how they're sitting and if their hips are lower in the back, right, than the front. And you can see if it's it looks like their knees are angled up because of that. So we can already get sitting alignment and sitting posture. And we're taking that into account.
I was thinking even like if there's a leg length discrepancy, is that can affect how
we'll see.
Yeah.
We'll see it and be able to measure it if we need to.
And you can see it, and can you have you seen so many cases now that you're starting to be able to?
Not yet. Yeah.
Or somebody with scoliosis that has that trunk tilt already.
We could. Yeah.
Okay. Yeah.
The trunk, the scoliosis is probably going to be hard to see.
Right.
Because the way naturally the Connect records is it puts what they call centroids, which is they put tracking here on your shoulders, and then they put a tracker here, and then it's all the way this long thing all the way down towards your hips. And so right now that is not being used. I won't be able to see the scoliosis. So we're doing like a side view and looking at the depth part of the camera to see if there's curvature.
So just describe it as like a stick figure.
It's a stick figure. Absolutely. Yeah. So like because of the two adjoining points, there's a long part in your torso that it just assumes the two are connected and that it's straight. So we are doing some recording from the side, what we call alignment, for that reason, just to see if there's some natural, curvature.
Nice.
But we're not going to be able to see like the actual spine itself.
Got it. What is like the average having right now on your test subjects? Is there any what do you think the average is in that T level?
We've gotten a lot of lower thoracics and then higher T4s.
Interesting. Not a lot of T6s and T7s. Okay.
Not yet, but I still have to filter through. So we just opened up enrollment basically in December. And then this month we've had several. And then I'm packing a lot for February as well. So we'll see more and more.
Oh, in December of 2024, like this.
Yeah.
Oh, wow. Very recent.
Fresh off the boat, fresh off right now. Yeah.
Wow. Okay.
Ambulatory clients, are they?
As long as they're still within the thoracic region, whether they're Asia A or D,
Doesn't matter.
we're taking them. Yeah. Because I want to see the variability.
Okay. Other questions?
And we have harder ones for those individuals on purpose. And so there's a force plate on their butt and then one on their feet. So anticipating, let's say we get like a T12, Asia D, who probably can stand some bits on their own. They're going to have some function in their legs. And during some of the leaning, my guess would be
Are the quad?
they can lean farther. And at certain directions, especially forward, they'll be the people that will off-weight a little bit onto their feet because they can.
Right.
And we'll be able to pick that up. Versus other people that won't be able to do that. And so they, won't go as far because, they'll plop forward. But if you have some ability to weight bear just a tiny bit, even on your feet, we have that force plate on the feet that will capture that. And that will be integrated into their, we think.
That'd be cool.
How cool.
Kind of a random question, just because of the certain topics we were talking about. You were talking about the Xbox 360 mechanism for measuring, and we were talking about how it gives you essentially a stick figure with scoliosis. Is there a way to modify the stick figure and get more localized and potentially be able to use that as a measuring device for scoliosis? Almost like an individual.
I would say not with the Xbox 360 right now. Even with motion capture, I think that's tough. You're kind of thinking about like an X-ray almost.
Yeah, I guess.
Yeah. And they don't have that good of, I don't think so. The Microsoft Connect Assure, which is the next version, has better depth, but it's more depth in what you can see in the view. And then, exactly. It's not really like through the body tissues to see that. So I would say no. But my guess is they're going to have certain movement patterns while walking that you will absolutely be able to start identifying because they do walk differently and their hips are going to be different because of that. So probably is what I would.
Okay.
Yeah.
Makes sense. No, it's kind of
It's more
off like a little.
Yeah, it's more based off of you'd have to have them do a series of movements. You have to have a lot of collections and then show, okay, someone with scoliosis has this type of movement during this type of task that's different than someone that doesn't. Yeah.
That makes sense.
Start to finish, how long typically is it for each person? You said it's 16 different
Tasks. That's a lot, right?
Yeah.
Without practice time, because we give them practice time the first session as well.
Oh, okay.
Some people are finishing as fast as 30 minutes and others it takes an hour. It depends on how much you rest in between.
Gotcha.
If you can run through each task, they're only the first couple tests are 90 seconds. And those are just static, seeing if you sway during the 90 seconds, eyes open, eyes closed. Then the leaning tasks. So if we don't have any problems with spasticity or that kind of thing going on, each movement only takes like a minute and then they rest and then they can do the next one and then they rest. So by the second session, because we have them do it the very first time when they're novice, and then we have them come back in 14 days to do it again, just to see if they're better or not. And by the second one, people do it a lot faster because they're familiar with it. So
more comfortable with it.
So even the higher thoracics I thought would take a lot longer. Yeah. And right now, you know, we haven't had any T1s. I don't know if you know any T1s out there. I don't really know a lot of T1s. But like the T4s that are complete can still get it done in like 30 minutes after practice.
Do anybody with the backlift pump? And is that something that would get in the way? Okay.
No, they could do it if they have the pump in. Yeah.
Okay.
Not yet though. It shouldn't be a problem.
Have you had anybody with internal stimulators?
No, not yet.
With that?
Yeah, they can't have the stim on.
Well,
It's cheating.
yeah, yes. But you would hope and think that.
We haven't.
Better function from being able to do it in a
so right now we're trying to just take novice, baseline spinal cord injury individuals, not with any kind of, I mean, if they were actively doing like a transcutaneous thing or something like that, I would want to, wait till periods where they were in between some things just to get their normal, natural ability.
Makes sense.
Yeah. But that's where it's going, right? So if you were to get stimulation in your trunk area, which those thoracic regions for X amount per week, whatever, does it improve?
And now you have a better
your trunk control.
Yeah,
we're hoping.
Are you in the retail, restaurant, hospitality, or petroleum industry? Looking for a trusted partner with your multi-site remodel, refresh, or tech integration needs? Look no further. Apex Imaging Services is your complete solution provider. With over 7 decades of experience, we're experts in everything from general contracting to cutting-edge tech solutions. Visit apeximagingservices.com to learn how we can transform your business, increase efficiency, and elevate your brand. Apex Imaging Services. Your vision, our expertise.
Kind of switch. One of the main questions that I wanted to ask, because I've seen it a lot and it's been asked a lot. You're a researcher in the spinal cord injury community. How would you describe what a spinal cord injury is? What happens in the body when a spinal cord injury happens?
That's a big question. Do you want to refine that for me?
I kind of want to leave it vague for you.
No. I mean, do you want me to describe my version of what I feel? Yeah. Okay. So let's just say it's like an electrical cord is what a lot of people say, right? Your spinal cord is basically like an electrical cord. It's just covered by a bunch of bone that protects it. And it takes signals from your brain into the spinal cord. Then it goes from there out through nerves to your muscles and then tells your body to move. But then similarly, the movements and the feelings that you have on your limbs and your body then get transmitted through that same cord and then transmitted up. It doesn't matter what kind you have or from what. The idea is at that area that you got injured, it's basically from that level, it stops all those signals or stops a lot of them, right? So if you have what we call, a transection, which would go all the way across that cord, you would hypothetically think then the top of that cord from the bottom of that cord is just not connected anymore. And it's not, right? Most people don't have that. They have like part of it, half of it, or bits of it scrunched or crushed. And so you'll get some of those coursing cords in there that are totally damaged, and then they all kind of just die back on both ends. But you'll have some that go through and that remain. And so the ones that are remaining, it depends on what they innervate. And then that could be maintained or brought back. But the ones that aren't, that get completely, severed or cut, each ends of those from the top and bottom are just going to start like dying back, which means you lose them. It is a little bit of a use it or lose it. So if they start dying back, then to get them to regrow, you have to either put new things in there to connect them, whatever that is. That was the idea with stem cells. That's still going on, by the way. They're bringing it back.
I saw they were talking about that at the Unite to Fight Paralysis symposium 2 years ago. But I love that you use the electrical cord because that's kind of my go-to analogy.
Oh, but it actually, have you ever seen a neuron fire on like a machine?
No.
So there are these things, EMG recorders, where that it's a smaller version of the same thing. Where if you have so there's central nerves that just go from the brain to the spinal cord. Then there's peripheral nerves, which are the nerves that are from your spinal cord out into your, muscles and arms and all that. So when a muscle fires, it's because the nerve gives it some kind of shock, if you will. And then it does the rest of what it does. So you can record that. And there's a recording when things are actually firing and neurons are firing, and they just look like these action potentials. And so that's why the electrical is the same, because it's almost like that. It's a signal from your brain. A thought is just like boom, and then it gets fired down, and then your body does it.
And I know this is not it's a very gray area question, but talked about there being some sort of still connection left with the spinal cord. It can be, yeah. On individuals, if there is still some more of that connection left on the spinal cord, so less damage to the spinal cord, is it always black and white? If there's more connection left, that the person's going to eventually have more function in total?
Depends on what those connections are. What if those connections left are pain receptors?
Right.
Not motor axons.
How do we figure out what those actual connections are that are still there? Do you know what I mean?
Oh yeah, by looking at someone? Yeah, right. I don't know. I mean, if I knew that, we would all...
Because you hear about like severe or less severe injuries. You hear about people going from complete to incomplete.
But what do you mean when you say complete to incomplete?
Spinal cord injury is what they're labeled as, a complete injury. And then when they go back and get tested again, and then the doctor tells them in a few months that, oh wait, you're not complete, you're actually an incomplete injury. And I'm saying totally based off what the doctor has told them.
Yeah. So what you're referring to, I'm glad you guys brought this up because I've been recently struggling with this myself lately, is the neurological exam.
Right.
So there's a neurological exam. Some people acronym it as the INSCI, if you have ever heard it, but that's the international standard for classification for neurological, for SCI, blah, 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 who cares? But it's a neurological exam. And what that exam is like I told you, we know that a signal from your brain goes into the spinal cord first. Right. Then from the spinal cord, it sends motor axons, sensory axons, pain axons out from there. Definitely. So the test is based off of that known anatomy, right? So each level, it's called a dermatome of your skin, is where all of those nerves come out. So like, let's say from your cervical level, those all nerves, the peripheral nerves, all go out to your upper extremities and then your hands and then your elbow, right? Then I told you in the thoracic level, you start getting into respiration, diaphragm, trunk muscles, and then lower, you start getting into the like hips and then legs. So we know that anatomically. So that exam is based off of every single dermatome. They do two things. If you've ever heard patients talk about this, and they do pinprick for sensitivity, right, for that, but then they also do light touch. And they go dermatome by dermatome to see, can you feel this? Can you feel that? So they'll do like a Q-tip, dermatome by dermatome on the left to see what you can and can't feel. And then they have a scoring sheet for every single level that you can feel. Same on the right. And then because it can be different, again, different nerves.
Definitely. Yep. Yeah.
Pinprick. And so they do pinprick the same. And then the way they determine it, it's like the lowest level that you can have sensation in both is your level. Right. And then the complete, incomplete by that exam is whether you, by all those different things, have motor areas that are complete and sensory that are complete, or whether you have just motor that's complete but sensory incomplete. And then there's different levels of that. So that's what that is.
Totally makes sense.
Incomplete can be three different things. So like, and we in the exam, that's called an ASIA grade, or, so it's either A, B, C, or D. Well, there's E, but E just means you're normal. And A is motor complete, sensory complete. B is motor complete, sensory incomplete. And then C and D, right? Same. So there's motor complete by a certain level, but still different levels of sensory incomplete. So it depends on what you're talking about, right? So traditionally so to go back to what you're talking about, if someone was, let's say, motor complete in the first week or two by that test of their injury, maybe they were called, T6 ASIA A. But then 2-3 years goes by, they do other things, they work out, but also just time. Then they might go back and get the exam and they might be still T6, let's say, but they're ASIA B.
Right.
So it depends.
Yeah.
And they could regain some things, but I don't know if that's the right word, regain, right? So if you test someone in the first week or two that they're injured, there's also a lot of spinal shock going on.
For sure.
And if some things were preserved, maybe they were preserved, but just not functioning properly. Right. And so is it truly a regain of function? Okay, you can call it that if, but it also could just be some of those were preserved and now they're, being worked out or woken back up. And so in that small amount of time, the first week or two that you're tested in the hospital right after your injury, it's probably when your body is going to be reacting the worst, right? So I think like a lot of people say too, like, oh, in the hospital area, they say after 12 months, whatever function that you've regained, that's it. Like you're not going to regain anymore. And that was based off of old paradigms and old testing ways and old thought processes. I mean, we used to think in spinal cord injury a long time ago in the research field, like once you cut that, you can never regrow it. It's just not going to regrow. And that's been debunked. It's not totally true, right? Some of those axons can regrow. Not all, and not always. Not for every person, not for everyone. Or at least we haven't gotten to that point yet. But some can, if you give them the right number of growth factors, or give them a median to grow on, or strengthen them. Or maybe they were just like sleeping. And weakened, but not totally dead. Yeah. And then if you wake them back up, stimulators, right?
Right.
They become more active. And then you've got to strengthen them. Once you wake them up, you've got to strengthen them.
That kind of reminds me of something in the research field when talking about axonal regeneration and people claiming, we got this regeneration, and it's like, well, what you're actually doing, you didn't regenerate anything. Something was already there and you woke it up, versus being able to actually regenerate a nerve that is completely severed from point A to point B, versus something there's not a sever, you're just...
Yeah. So scientists like to argue about this all the time.
That was a lot.
The term sprouting versus regeneration.
Yep.
Are you or a loved one living with paralysis and searching for a path to recovery and hope? Look no further than The Perfect Step. Our unique exercise-based recovery programs have helped clients with conditions like spinal cord injury, stroke, Parkinson's, and more. With our approach, many clients experience improved function, reduced medication, and even freedom from wheelchairs. But we're not just a program, we're a community of support. You'll meet peers who understand your journey, along with specialists dedicated to your recovery. Visit us today at theperfectstep.com. The Perfect Step, where recovery begins.
Can I ask?
Can we talk about that difference a little bit? Yeah.
This gets a little out of my domain, but because I'm not a regeneration person.
That
But
was one of the big topics at the symposium. It was kind of cool because you got researchers from both sides, and one claiming like, look, you can't claim regeneration when you're just sprouting, and others saying, no, like it is regeneration. And so I'm kind of asking.
yeah, so if you imagine just like, an axon is this cord, right? It can have all these little collateral branches on the side that go to other areas, but it's got one main branch. Let's just say it's like a tree, right? One main branch and then these little things on the side. And so if you get the main branch and you cut it, and then that main branch, you put some secret sauce in there, and then that main branch, regenerates or grows again, then it's regeneration, right? But what if the tip of that is cut, you give it some stuff, and then it starts growing things all on the side and creating this other new network? What's that called? Right. And so it's not just that, but it could also be that it's a flaw in the way that we measure these things in animals. And there's partial flaw in that, in the sense of, we can't really live capture, go into an animal, cut one axon, one specific one we're looking for, then give whatever drugs or therapies we're going to give interventionally, and then do a time thing and track that one all the way through, right? I mean, that's what we would love to do. And you can do that in a dish, potentially, but in even rats and mice, that's hard to do. You can't do that. So it's just a caveat of the way that we test things in animals, wait a time period, then sacrifice those animals, take out their cords, and then start looking at what they did and image it. It's a caveat of that. And that's where the whole argument comes from. Because you can't do what I said. It's like, okay, let's just cut these two. I mean, we can do we cut one side. Well, I don't do it anymore. The Irvine does, where you do just call a hemitranssection. So you just cut the left. So you know everything on the left, and then you label it in the animal, or you take an animal that specifically got certain motor neurons pre-labeled that way, a certain color. And then you do your treatment, and then you see, do those ones that you've labeled red cross over? Do they not? Where are they going? Then you can do that. Yeah. But that's kind of the best way that we have right now. You can't actually pick all of the ones that you want and then track individually those. You just end up collectively tracking in an area.
And even with human subjects, you can't.
You can't do that at all.
Yeah, you can't do that at all. So,
Yeah.
if somebody is gaining back a function, there's no specific way to say,
No.
sprout it around, and that's what
we have no idea in humans.
Main severed. So there's no really way.
We have no idea. Yeah. And so that's a contentious thing in the clinical world for spinal cord injury too, is people, activity-based therapy. I mean, we're here, right? Yeah. So let's talk about it. So, someone's maybe 6 months out, they think they have some residual functioning left. They're doing these exercises, things that they think are going to be strengthening, let's say, those particular muscles, and then they see some strengthening, right? How that's happening, we don't know. And there's no way for us to look inside of them at this point and go, oh, okay, this is what's going on in your cord, right? We just have to guess based off of what we know in the animal conditions is happening, and theorize that that's potentially also happening. But it is kind of a big jump, right? Going from the animal models to the human, because the animal models are always going to be clean, precise, and exactly, in that we've gotten very good as scientists, and the scientific field has gotten very good at doing the exact same injury for 30 animals the exact same way. But in humans, that's just never what's happening. And so it's different, because how humans, what theirs even initially looks like, is already going to look different than what we do in the animals to mimic it. We're not in that perfect scenario yet. It's obviously cleaner.
I think,
plus there's just species differences.
Definitely that. I think that's the biggest one. But I think what I kind of go back to is something you taught me at that initial Meet the Researchers, was you explained the spinal cord injury and the matter of how deep into the cord the sever goes with the gray matter, that's going to be dictating somewhat the amount of damage it actually does. And the way you described it really helped me kind of understand that component of however many millions of nerves or neurons there are, no injury is going to be the same.
Probably not. Right. Yeah.
Because, I guess probably, but with human models, because every injury is different, no matter what you are going to be doing. You're not going to be able to say it's this or it's that, because
Yeah.
every single subject is going to be different. So
Yeah.
from a research perspective, I feel like that makes it
Hard.
extremely hard to
It
prove
does.
validity.
Yeah. I mean, and you probably see this too, like in humans, 2T6 Asia A's may not perform different.
Yeah.
Or they may not perform the same.
Right.
And parts of maybe how they perform maybe are the same and parts are not. And so is that from the original injury? Yes. And probably how the original injury happened and what got damaged, right? Which, you functionally at that testing level, you're the same T6. But inside your cords, you may not be the same. Different areas are going to be completely different.
So maybe more motor, more.
Right. One could be more motor, one could be more sensory, one could be across the entire cord, one could be just this tiny little piece. And so, yeah, you just by staring at them, you don't know.
No idea.
Yeah, you're making me feel really bad about my outcome right now. This is something I've definitely been thinking about though, because, of course, I was very lucky. It took me a while, but to get the grant funded to do this study. And I was very lucky that Craig Nielsen funded it for me. And actually, I was very fortunate because the reviewers on my first submission were so helpful about, what about this? What about that? Have you thought about this? And so they made a lot of really good comments that needed some changes into the way I was designing the study. Things that made me really, really think, because the truth is no two T6s are going to be the same, two T6 Asia A's. And then does that mean I'm going to be able to see a pattern in their movements? Am I going to be able to design something testing wise enough to see those patterns, considering all the other things that it could be? How am I going to standardize that? How am I going to know or standardize it enough to know when we still don't know a lot about what's going on in that area? The other thing that I'm running into, the reason we brought up the neurological exam, is there are some issues with that exam. It's not perfect either. So even though you do the light touch and the pinprick, you also test, the motor strength, but only for the upper extremities and the lower extremities. They completely skip the trunk, which is what I want them to do, right? There's no tests to do the motor strength in that area because we don't have good tests for even that. So it was never incorporated in. So that's another caveat with the thoracic level, right? You could get some people in that middle region, maybe T4-ish, that have a lot of muscle innervation in the trunk left, and someone that doesn't. But because of the way the exam is, they're both considered the same because those muscle strengths in that area aren't being, they're just not being tested. They're just the same on the arms and then somewhat the same on, sensory and enough that we say that. But it could not be possible. I don't know. I mean,
Do you think that will ever become a thing that they'll start to incorporate?
no, we need to talk to the Asia guys about
How
that.
would you like for it to be done? Like a muscle component, or like you're saying, like testing the diaphragm, or?
I know. So some of those things are just so hard to test. I mean, you could get some muscle activation, through the EMG, but you're poking people. And so then you have to think about, do we really want to be poking people even more and deeper, right? And that's the problem with some of the core muscles. Some are surface, the ones we all think about that are surface, right? You have your rectus abdominis, all the surface ones, the six pack that everyone talks about. And then your external obliques. But how would you test like
Transverse.
Right. How are you going to get all the way in there? That's just a tough.
Invasive.
Right. Very hard.
You mentioned
So I don't know if it's ever going to be added because it's problematic.
Yeah. You mentioned earlier residual, leftover after someone's injury. So would that be incorporated also by something that we call spasms? And what exactly are the reason why some people have those spasms and some people have more control of their spasms than others, and some have ridiculous tonicity over some others do as well. And that can be the same level of injury. Does that still go back to how severe the spinal cord was damaged? Yeah.
I know from my training that you'll see people with incomplete injuries that have more spasms than complete.
Definitely.
That would come from the theory of, innervation.
Right.
Right. So if you have less innervation or no innervation to those muscles, then they're probably not really going to be activated in that way to spasm. I know there are different, this is not my specialty, as far as like the difference between the tone and spasms. It's a different function of the muscle. And so, someone that is really just rigid and stiff, you're just basically like pulling their muscle stiff and taut. It's different than a spasm that's actually
where it was.
activating.
Yeah.
Neurologically, I don't know what's going on there though.
Or clonus. Like that's something I think about a lot too. But I have questions with it. Very interesting.
There's so many different components to Maya. Besides for your current study that you guys are doing, what components of SCI research are you making most excited for the future?
I am actually very excited right now about all this transcutaneous stuff. I really am. The epidural is hard, because it's invasive. And I have heard at the Unite to Fights a number of people that have had them, some not so happy with the results of it. And so they've had them taken out. And so it seems like a lot.
Yeah.
For maybe, again, obviously there's been some videos and things that are very promising. So that's hard to ignore. I think the thing is we just need, as always, we need to do more research on it and figure out why it works for some people and not for others, and who are those what we call responders. That's why I'm excited about the transcutaneous, because it's kind of the same idea, but it's not as invasive, so it's not permanent.
Yeah.
And so maybe then you have a little bit better control of it, perhaps.
For somebody who doesn't know the difference between transcutaneous, can you?
Yeah, sure. So transcutaneous sounds like it's word. Trans is just above or outside, and then cutaneous is the skin. So you're basically putting kind of like a stimulator, something that gives little shock waves on the outside of the skin. Epidural, those epidural stimulators go inside and under your skin, and they're right up against your column. And that is going to obviously transmit a signal, a lower leveled signal, farther, or it could be better in that way, but it requires surgery. Yeah. And so that's the problem with it too, is the surgery part. And then you have some potential surgical complications, just like the backflip pump, to be honest. Same kind of idea.
Yeah.
But the transcutaneous is just at least on the outside, so it should be safer. It's obviously not what we call invasive because it's not going inside or underneath the skin. And it hopefully does something very similar. There's been a lot of success, like Onward and
I've seen a lot of them. I like them a lot for the functional activities. So for people who do work at a desk job, or when they're driving in their chair and they use it for postural support.
Yeah.
I love it for things like that from a recovery side, or talking about,
But will it be enough?
will it be enough for certain individuals, or will, they need the epidural stimulation? I'm trying to find a way to balance that of if somebody isn't trying to use it to gain back lower extremity function or for walking or taking steps, for those who do just want it, for a postural support or something like that, finding out the balance of how can we make the transcutaneous as good as the epidural or as strong. And
As strong.
but yeah, I think where I get most excited for it is
Yeah.
being able to do some of those more functional activities in a better manner, and just, posture's gonna be good for
yeah.
everybody.
Yeah, that's why I kind of said that too, is like, I know there's a certain, not just in the research field, but in the community side too, there's a certain, group of people that really, really just want to walk again. And that's definitely there. And I get that. And so if that's the main goal, I don't know yet, how far we're going to get with the transcutaneous. And so I'm not sure. Right. But when it comes to the other cohort, that I talk to a lot of individuals in the community, and this has been said to me a number of times. It was relative to when I was talking about arm function actually with someone, but it does translate into the trunk control. But they said to me, they're like, there's nowadays, the chairs are so good. You can get so many good chairs now, as long as you actually can get it sent to you and made. But chairs do a good job. Wheelchairs do a good job. You can get around. You can be pretty mobile. At least in the US, things are usually compliant. Yes, certain things are still hard, but you can still be mobile and get around in a chair. But what happens when you can't use your arms, right? That's a lot more that you can't do. Same thing with if your trunk is so poor that you can't properly use your arms, which is what I always go to. So I am going to integrate the two at some point in my career. Because the two are affected by each other. So like you said, just proper posture, not only for lower back pain and nerve pain possibly, and for your sitting upright in your chair, but it's also for eating properly, activating your arms to be used properly in tasks as well. And so I'm excited about that because I think on the day-to-day, more widespread help will come from that. Yeah. That translates into something at home that will be better. So you're a little bit more independent.
I saw like a combination.
Even though you're not walking again.
I saw a combination of those two, like the reach and grasp function mixed with the postural support, and people being able to open their fridge when they hadn't been able to do that before just because of that continuous
I think you have to set your spine and your trunk first proper to even have the full reach if you have the function of your upper extremities. And so those two play into each other. If you're always scrunched in the back, you're still not going to be able to reach everything that you want to reach. So it should help, but it also, a lot of people do sitting in a chair a long time, all day long, and then in a car all the time, don't have good posture. You're going to get some lower back pain, and that's going to be a problem. If you're doing that and have lower back pain and you're manual wheeling that way, you're going to start having shoulder problems and rotator cuff problems. So there's a lot of things that down the line additively come from that. That I mean, I haven't proven all of that, but conceptually, that's where a lot of it comes from. And so I think it's important as a good realistic step of improvement and independence. Not to say that walking isn't realistic. I think it's getting there. I mean, we're more progress than we've ever been in the field in a long time. So there's a lot of positivity there. I've just personally, obviously, given the domain I work in, think there's a lot of progress to be made and you're still not walking yet. But improvements at home, improvements and independence.
Yeah. And some of those improvements are also like such big deals to a lot of our clients, especially like you said, being able to open their own fridge or being able to, if they do fall forward in their chair, being able to pull themselves back up.
Yeah.
Feel independent to do so.
I mean, even just being, if you've had any kind of fracture and you can't feed yourself, even if it's 2 weeks, you lose a ton of independence.
Definitely.
And that loss of independence leads to a lot of other cascading things. Right. And even if you only have it for 2 or 3 weeks, people are like, oh my gosh, it's like the most depressing time that you can't feed yourself, dress yourself, So a lot of that when you don't have it is very, very important. Whereas more important than maybe walking. Right. It's like, do you want to walk again or do you want to be able to like be independent, dress yourself, bathe yourself, eat? Prepare your own food maybe by opening the fridge, opening shelves,
Yeah.
A lot of people would actually maybe not choose what you think.
Yeah.
I mean, the research field was obsessed with walking for majority of this SCI research, time that people have been doing research. Even in the animal models is always regaining locomotion.
Is that kind of when like CPGs got a lot of popularity?
Yeah. I mean, it's the same era. Yeah, because it was all about regeneration, and the point of regeneration was to walk. Yeah. It's changed a lot since then, which is good.
Can you walk us through like a day in your life in
it was boring
right now? It doesn't sound boring.
It's much more exciting.
It does not sound boring.
To the average person, a researcher's life, like we talked about earlier, how I'm just like horrible on social media, right? And I'm trying to get better. I actually just finally made an Instagram account for myself for my lab. And it's because it's like, I mean, do people really want to see what we do all day? Like,
I think there is
I mean, it's
a good amount of people who actually do, though.
wonder. Yeah. I can tell you like what my week is this week. So because I work in clinical research, I do have, like right now, when we're recruiting for a study, a large number of days dedicated, full afternoons dedicated to these subject appointments. So that's actually a lot of fun. And so the subject appointments, when I'm there, I'm doing either the guarding of the balance testing or I'm showing people what to do. So that can be like, so like this week, I have control subjects coming through all day Wednesday in the afternoon. I've got some SEI community people coming in Thursday and then also Saturday. And then in between, right now I'm writing a grant with some colleagues. So in between, I'm just sitting with two big screens on my desk, like feverishly writing all the details of like study design and nitpicking every little word and that kind of stuff. Other days, I spend half a day or a full day doing data. And data can be just like think of your worst nightmare with an Excel spreadsheet. Because I do motion capture. So think of your worst nightmare of an Excel spreadsheet, and it's that. And then trying to stick that in and merge it with other documents like, spinal cord injury level, demographics, whatever. And then I'm sticking that into like statistical softwares and then trying to figure out how to look at the data, how to analyze the data. And then other weeks, I could spend a whole week sometimes analyzing data and producing figures. And that will be like my whole week for like 50 hours, 60 hours. Yeah.
You mentioned that you teach too.
Yeah, I teach intermittently right now.
Okay.
Because I do a lot of clinical research. I'm not a basic scientist. My teaching right now is a little bit less, but I teach medical students and or residents. So at UCI, we have this master's program. It's called the Master's Program for Biomedical and Translational Science, so MS-BATS. And we get people that are either individuals that just graduated from college, or we can get MDs in the program. And the idea is to teach them how to be clinician scientists. And so the teaching is teaching them clinical study trial design, teaching them statistics, medical statistics, teaching them how to construct a grant. So how to come up with a research project, hypothesis. Then once you come up with the hypothesis, how do you actually set up a study design to test that hypothesis, critical thinking skills, that kind of thing. Awesome. So right now, like in the fall, what I taught was clinical trial design and the different types of adaptive study designs, what the components of them were. You bring up papers, you talk about them, the pros and cons, why they were used, their advantages, disadvantages. So that's a lot of the stuff that I do. I'd like to get into some other teaching, doing a little bit more like movement-based. Right now, it hasn't happened at UCI. There's like not that kind of a niche yet. But yeah, and a lot of that is that kind of teaching. So then I'll do like teaching with the residents, and it's teaching them research, how to interpret it or how to design it. Like how, if they want to do their own research study, how would they design it? What do they need to be thinking about? How to put it together so you get something.
How long have you been teaching for? No?
I don't know. In that domain, probably only 2 years.
Okay.
When I was younger, I did a lot of actual lab. I would teach like a molecular bio lab and that kind of teaching to the undergrads. But I haven't done that lately. Yeah.
Nice.
I'm trying to focus more on the clinician scientists.
Yeah.
So teaching the doctors and MDs that want to go into research, or, OTs, PTs that want to get into research as well.
Really cool.
I have a couple of my mentees that are like that.
Nice.
Well, Maya, thank you so much for coming on and spreading just your wealth of knowledge with us specifically and our entire community. I think you gave a lot of great information that a lot of people do really want to know.
Yeah, happy to come back, talk whenever when I actually have results, maybe.
I'd love to be back on. That'd be awesome. Yeah.
You can get finished with your study.
Yeah, still recruiting if anyone's interested.
We will send.
Okay.
Is it just?
Yeah.
It's posted up. Yeah, but I can still give you guys the
Send it
information
to us
and
we
feel
can
free to
post
blast
on the
it.
front
Yeah.
door, yeah.
We'll share with the clients. Yeah.
Yeah.
Thank you so much.
Thank you very much, Maya.
Thanks.
Thank you so much for joining us on today's episode of Pathways to Healing, the Perfect Step podcast.
Please remember to like, comment, subscribe, share, and feel free to leave a review by clicking the link in the description below.
If you have any feedback or topics you'd like for us to cover in upcoming episodes, go to our website under the tab Pathways to Healing and fill out that form.
Until then, keep inspiring, stay resilient, and roll on.